We are live. Okay, hi, welcome. Today we are gonna be back working on the little platformer game that I worked on a couple of days ago. As soon as I showed the actual window for that, let's see. And it's that. Wow, that's amazing positioning there. There we go. So, this is what we've got done so far. It's not much, but today what we're going to be working on is the actual character controller. And we're going to try to finish that today to the point that it's actually good. Because currently we just have the very basic default thing, and Steam appears to be saying something. I also don't show the game. Let me just show that. There we go. And that on top. There. So this is what we have so far. I'm gonna move that down there. And this uses the default character body 2D template script, which I really don't want to use. And let me just disable that. That's a bit odd that it does that. Huh. You know what? We can keep that then. We can keep that. Yeah. So I think we might need a state machine, a very basic state machine probably. Now a state machine essentially holds all the states of a character, like when it's in the air, when it's idle, when it's running, and so on. And I haven't ever made one of those, so this is gonna be a very nice adventure we're gonna make here. I did not check if I have audio on. I do, and I also have my headset set to ear rape. Okay. So I also gotta check that no audio is echoing, which it shouldn't be because I haven't changed a single thing. That should be all good. So I can do that, and perfect. So first of all, let's go to the main character scene. And we're gonna need to open the script. Good, this is excellent. Velocity.y plus equals gravity times delta. Okay, yeah, that's correct, yes. And yeah, that's correct because I didn't do it. I didn't make that. And this, I believe, when it comes to physics, the velocity, I think the velocity applies delta automatically, which means that I don't need to include delta when setting the velocity. Which actually makes sense, I think. Yes. So how do I make a state machine then? That's an excellent question. Now I've been looking at this one, I don't know, page. I've been looking at this one guide on making a state machine. And at first I didn't entirely get the point of the state machine, but then I realized that the state machine was already obvious to me, because this guide shows that a state machine is much more efficient and better than just using a Boolean variable for all the different states. Which I didn't even think about really using Boolean variables. I just thought about using the state. But then the guide also introduces a more complex way of making the state machine. And after reading through the entire process, I came to the conclusion that I understand absolutely nothing about it, and I don't know why they make it so complex. And I don't think that I'm gonna need such a complex state machine. I think I just need a basic state machine. So that's what we're gonna have to do today. I also learned more on variables and the node paths. That. So if we have time after making the state machine, I'm gonna try to import a tile sheet, which I worked on the last stream I did on this game. And we're gonna see if I can make some sort of a level. During this stream. So let's get to making this then. Okay. I'm gonna have the guide open on the side so I can look at it for reference. Because I am not entirely sure how I'm gonna do this. So wait, that's the more advanced one. I'm not gonna make the more advanced one. No. Okay. So wait, there, okay. A simple solution to this problem is to define a variable named state that stores a text string or a member from an enumeration and helps you keep track of which state the character is in. You can then use it in conditions or in a match block to know what the character can or cannot do. That is a simple description of a state machine. It is basically just what the player can and cannot do. Now, this, we're probably going to want player extend class name state. Ooh. So in a more advanced state machine, each state would have its own class. Or actually, no, all classes would have a base class called state, and then there would be a class called state machine, which would then handle the states. And it's absolute mess to make it once, but you only need to make it once. However, since I have never made a state machine before, even a basic one, I'm gonna have to make the basic one. So what we're gonna do is we're just gonna find enum states. Sure, we'll make it an enum list of states. And what are we exactly going to need? So the player will be able to jump. They're able to move on the ground. You could call it running, but it's a marshmallow, so it just kind of hops along. When the player is in the air, they would have probably the air in air state. But I'm also thinking if we literally have only on ground and in air, then we literally have no reason to make a state machine in the first place. I'm not gonna make a state machine just because I want to make a state machine. I think we might have a double jump ability, which can only be triggered when the player is going up on the y-axis and not when the player is going down. This I'm not entirely sure of yet, because I haven't really refined any of this. But something that I do know I want is the player bouncing off of walls, which actually, now that I say that, I need to make sure that we have a wall and... Whoops. We have a wall and we can test out some physical properties. That's the wrong thing. Okay. Let's put that there. Now, if I'm correct, we should be able to just run this and hang on, let me just check. Oh, beautiful. Very beautiful. It would seem as though this does not detect that. Huh. Okay. Hang on. It appears that it does not want to show the playable debug window now. Why? Hold up. Hold up now. That's good. We just want to hide that and show this and then hide that when I do that. Or just show this, do not that, do not that either. This. Hello? Yeah, oh, okay. OBS really does not like to detect that now. That's odd. Really odd. Okay, let me see if I can detect at least this. And that should function. Okay, that functions. It's okay, that functions, yeah. So now we have a wall here, which, well, when we jump at it, really nothing happens. What I'm thinking I want to do is have the player bounce off the wall. We also want to remove control from the player when they are in the air, which is one thing that we can have the state machine for. Plus, I'm thinking as this project progresses, I might add some special abilities, like the double jump that I mentioned, or other abilities that can only be triggered when they are either falling or going up. So we'll see now. Let's hide that. And I'm gonna put myself down here. So first of all, if I want to make the character bounce, I would probably use the... let's see, we'd probably use... not that. Hold on. Input, transform. This... okay, that material is canvas item, collision object 2D, pickable, disable mode, remove. Now hang on, I gotta check something. So a rigid body 2D has various different things. It has mass, inertia, center of mass, physical material, blah blah blah, gravity scale, sleeping, freeze mode, linear, angular. You're about to not see this. Force is constant. Okay. Collision and input. Okay. I just had to check what exactly the rigid body 2D has. Actually, I could show the entire screen. I could, but I probably won't. Apparently. Okay. Let's see, the collision shape 2D then. What do we have? One-way collision, disabled, shape, transform is there. I thought that there was like physics material. There is a physics material. Where do you use a physics material? Like, because it says when I hover over, you can't see it. God. Okay, where is it? Display capture. That. So when I hover over this, it says holds physics related properties of a surface, namely its roughness and bounciness. And the bounciness is the thing that I'm looking at. Like, I am really interested in the bounciness, but how exactly... what exactly do you apply it to? What exactly uses physics material? That I don't know of. Physics material. I'm looking up on the docs now to see if I can find anything. Because, like, the character body 2D, it's pretty much entirely just programmable, as it says there. Rigid body 2D is moved by physics simulation. The static body 2D then can't be moved by external forces. When moved manually, it doesn't affect other bodies in its path. So okay, so the static body 2D has this physics material. So that means that I would have to apply to all walls the physics material. instead of the character itself. This is gonna be interesting. So if we make a new physics material for this, we can edit this physics material right there, and we can edit the bounds like that. Now if we just try this out, absolutely nothing happens yet. What I'm gonna try is I'm gonna scale this down to the point where we can jump on it. Okay, come on. And either A, the bounciness is too low. Just absorb it too. If true, subtracts the bounciness from the colliding object's bounciness instead of adding it. Okay. Again, I'm aware that it's a bit odd at times, the way that goes. Okay, so it seems that the bounciness does not affect the character. But if I was to, like, say, duplicate this, move it, whoops, move it, whoops, move, goodness gracious. Okay, move that like so, and we're gonna remove the, actually no, we're gonna change the type of this, change the type to a different body, which is a rigid body. Just gonna experimenting with things right now. And we're gonna make sure that it falls down. I know that things are looking a bit odd for you, but that's because the capture over there is a bit odd. Okay, I see. So the block did not fall down. I should probably also move these to the center of the screen. Or rather, change the camera somehow. But I'm gonna change the position of all of these. I have the tile map there just for future's sake. Again, I'm moving the root as well. Okay. There. So now, okay, I forget to set that. So that thing up there does not fall currently. I want that to fall. We're gonna change this. There we go. So, oh, well, I see. Oh, it's called a static body. It's actually a rigid body. We're just gonna name that for convenience. And the rigid body does have a physics material. How did I not see that before? Does the character body have a physics material? I don't think so. Like, wouldn't it be... No. No, most certainly it is not here. So, yeah. Okay, then. So, freeze mode, static, kinematic. Freeze is off. Mass, inertia, center of mass, gravity scale. Technically speaking, shouldn't this thing be falling right now? Like, if I play and I show this, should that thing not be falling right now? I feel as though it should. But maybe I can do kinematic on that. don't know, maybe I'm just being stupid and this isn't how it would work. It does not fall. All right, hold up. This needs to be resized. Whoop. Whoop. And whoop. Whoop. That works properly now? No, it wouldn't. Of course it wouldn't. Okay. I just undo some things here. All right, cool. Steam, thank you, Steam. God. Okay. So how would we make this thing fall? Continuous CD. Collision detection mode. Okay. If we disable sleeping, I don't know. Like it has center of mass, it has that, it has a gravity scale. If I just do that. Nothing, okay. That's just convenient now, isn't it? Yeah. This, I'm gonna resize that to be completely filling the screen. Okay. And disable that. I don't know how a rigid body is supposed to fall. Rigid body. Using rigid body. How to control rigid body. No, that's all supposed to be one sentence. Rigid body 2D. Physics introduction. We're using rigid body 2D. One of the benefits of using a rigid body is that a lot of behavior can be had for free without writing any code. For example, if you were making an Angry Birds style game with falling blocks, you would only need to create rigid body 2Ds and adjust their properties. Stacking, falling, and bouncing would automatically be calculated by the physics engine. Bouncing is what I'm looking for. However, if you wish to have some control over the body, you should take care. Altering the position, linear velocity, or other physics properties of a rigid body can result in unexpected behavior. If you need to alter any of the physics-related properties, you should use the integrate forces callback instead of physics process. In this callback, you have access to the body's physics direct body state 2D, which allows for safely changing properties and synchronizing them with the physics engine. For example, here is the code for an asteroid style game. Okay. Okay, I think we might have to calculate the bounce then. we might have to do the physics calculation so we can add a proper amount of velocity when the player bounces off a wall. So that's gonna be interesting then. Bodies detect collision with other bodies, but are not affected by physics properties like gravity or friction. Instead, they must be controlled by the user via code. The physics engine will not move a character body. Well, okay, a rigid body 2D should move on its own. It should move on its own. It should move on its own. If I just delete that node, yep, and then add child node, add it again, and give it a shape, not shape cast, collision shape 2D. And we need to give this fella a shape. Let's give it a nice rectangle shape. That's too big. We're gonna scale it. We're gonna okay. I was looking forward to having a properly scaled block. There we go. Okay, so this should fall. It should fall. What if it doesn't? Well, it doesn't. It just doesn't. I don't know, maybe it is good that I use a character body 2D, but also I kind of do need to figure out how to make a block fall if I'm gonna make an entire game in this engine. What if I change whether the block can sleep or not? Oh, you can't see that again. Okay. Ah. Okay, so can sleep, true. Linear, velocity, damp, angular. Rigid body 2D directly is the play forces to it, and the physics engine calculates movement. So you gotta apply a force to it still, yes. So if we just apply a negative 20 and I added a constant force to it, but it appears to not work. Then that should actually be... Okay, that is good. All right. So, yeah, it doesn't fall at all. Okay, I might have the wrong idea of this then. If I apply negative 20 on that, then do this, it does nothing. Got it. What do I do then? Okay, so I would expect it to I would expect it to fall because it has mass and it is supposed to be affected by gravity by default. But if it is actually that I need to apply an impulse to it, I can't possibly do that for every object. You must apply forces to it. Yeah, I gathered that much. Implements full 2D physics, it cannot be controlled directly. Instead, you apply forces to it. Rigid body will always maintain its shape and size, even when forces are applied to it. It's useful for objects that can be interacted with in an environment, such as a tree that can be knocked over or a stack of crates that can be pushed around. Aha. Okay. But how? Am I literally gonna be figuring out one single thing for the entire stream again? Like, you gotta be kidding me. I can't be doing this for the whole time. Default gravity value. What is the default gravity value at then? Physics to the default gravity vector is 1. So really it should move down. Huh. Huh? But this moment of inertia. This is like mass, but for rotation. Well, that doesn't help me a single way in any way. Vector applied to area 2Ds. Really? It should. Oh wait. Am I? Oh. Okay. I appear to just be stupid. Okay, I'm gonna delete that and I'm gonna make a new rigid body 2D. Oh god. Oh no. We want to add a sprite 2D and then a collision shape 2D. And then we want to give this collision shape 2D a new rectangle shape 2D. This thing as well, we want to give a let's see, what do we want to give it? I think not that. Yeah, I get it. Or reset that. Canvas texture. Right? No, that's not the thing I want. Okay, hang on. Let me see. What did I apply here? No, that's a canvas texture as well. Okay. Sprite. How small are you? Texture, normal map, diffuse, resource. Okay, really, it should be much bigger. Now, if I... Oh, goodness. Now, if I move... Oh, for the love. Now, if I move that over there. And now, if I play it... It's okay. This is the best way to learn. If you make mistakes, and if you suffer an immeasurable amount, you will learn more. Oh, God. I can't believe I spent like 40 minutes figuring out that the order of a rigid body matters. Like, the rigid body was functioning the whole time. Just the sprite wasn't moving with it. The sprite was just staying still, making me believe that the rigid body was staying still. But it wasn't. It was moving. It was just invisible. Oh, God. Okay, now that we have figured that out, I need to decide if I want to have the character body 2D as the player or a rigid body 2D as the player. A rigid body 2D has the option for bounciness with a physics material. But it can also be more unpredictable, which isn't exactly something that I want. Then, however, if I want to use the character body 2D, I would have to calculate the angle at which to move it. At the angle, not the force, the entire vector, the entire vector 2D force that we're going to apply to the character when they bounce off a wall. So when they collide with a wall, we would have to check at what angle they collided with it. Now, how are we gonna do that? I suppose we would take the velocity from the previous frame and not inverted, because that would go towards the wall. No, it would go... Hold on. We would want to invert it on like the y-axis. And then we can modify that. I believe. Also, this, oh dear God, when anyone sees this, when anyone experienced with Godot sees that setup, they're going to be horrified by what they see. So I'm just gonna fix that up, and we're gonna make this. Hang on, that actually shouldn't be a canvas texture, because a canvas texture is used for hold on, where is this? A canvas texture is used for UI elements, I'm pretty sure. That's not exactly something we want. So let's see. Placeholder texture. That would be the one to go for, I believe. Placeholder texture. Then we're going to add a collision shape 2D to that. Create, and then add a rectangle to it, and we're gonna scale that down to match the size of the texture. Nope, the other way around. We're gonna scale the texture to fit the collider. And then, oh boy, oh boy. Is the collision shape 2D supposed to be at the very top? No. Can't be. Cannot possibly be. But we are supposed to do that. That doesn't scale. Why doesn't it scale? Oh boy. Well then. Should we have that there? No, we shouldn't. Should we have that in there? Also no. How would we then scale both of these at the same time? What actually changes when I change the size of this? Because it's not the scale. And also, I believe that I don't actually need to move the... I don't need to move the static body. Oh, for the love of it. Oh. Just... I'm starting to see why different scenes are used for different objects. Because then you literally need to only modify one object. That's it. Okay, let me try this out. Okay, it still functions properly. And this block is very much not going to nudge at all. I didn't mean to rhyme there, but it just did. It just happened. Now what did I apply the physics material to? That's just very bouncy on its own. Oh, never mind. It's not very bouncy anymore. Okay, we're gonna add a new physics material and we're gonna change the bounce. Okay, that's good. That's good. I don't know what Steam is doing there. Hello, Steam. Shoo. So this guy is now here to stay. How do you like him? He's just there. It's not doing much. He's just gonna is there. Okay. Good. So we need to change up some stuff. Why are both of those being changed at the same time? Why do they both change? They're named the same way. That doesn't change it. But it's because their shape is the same. And I'm editing the shape. Is the game gaming? No. Oh my god. Am I stupid? Or am I dumb? Wait. So I spent about half an hour or 40 minutes maybe figuring out that a rigid body should be first in the list. It should be at the top of the nodes when you want it to actually take effect. You know, it makes sense if the sprite 2D is inside of the rigid body 2D so that the sprite 2D can follow the rigid body 2D. So that took me half an hour. And am I glad about that? I mean, yeah. Yeah. Sprite 2D is the child of the rigid body. Yeah, it makes sense. It does. It really does. I just didn't think of it. Whoop! What are the shortcuts? W S E. W S E. Okay. W S E. No, that's S. Oh, Jesus. So this is all still placeholders. And I'm trying to figure out if I wanna do the calculations for the bounce or if I want to use a rigid body 2D for the player character. Does lobs work? They should. I'm not gonna try, but they should. So I'm gonna try something. When... Wait, how do I detect collision? Oh, shut up. Oh, shut up. Um, good. So I just realized that I haven't actually detected collision between two objects. Nope. Huh. What's the is there is there perhaps a built-in event? Is it an event even? Is it called an event? For detecting when something is hit. I would probably have to make this extend the collision shape to the Jesus. Oh god, this is gonna be a pain. So is the signal here? Collision object to the input event. Mouse. No. It's gonna be a problem if I can't figure out how to do that then. We're gonna have to. Is on floor is just an inbuilt function. Is on floor. Yes, is on floor is in character body 2D. Um, hang on, I think somewhere here. Change type, rename, no. Yay. Okay. How do we go about this? Time to go on the docs then. Okay, character body 2D. Properties, methods, live floor snap, get floor angle, get floor normal, get last motion, get last slide collision, Get platform velocity, get position delta, get real velocity, get slide collision count, get wall normal, is on ceiling only, is on floor only, is on wall only, move and slide. So there's literally something for everything. It even gives us the info whether it's on wall or on the ceiling, which, wow. That's quite a lot of things. But none of that helps us with collision. So I need to check the collision shape then. Collision shapes. Collision shape 2D. Primitive collision shapes. Collision shape. Rectangle shape 2D. Okay. That just has a size. Okay. Collision shape. You can define the shape of a physics body 2D by adding one or more. Okay. Physics body 2D is what it inherits. Get collision exceptions. Move and collide. Move and collide. Okay. Okay, let's see. Or globals? No. Classes? No. Okay, let's see events if I can find. Input examples. I don't think that's what I'm looking for. Input event. No. I get the feeling that this is gonna take a while. Collision shapes, physics properties, collision shapes, collision geometry only, 3D particle collisions. Jesus. Raycasting, 3D particle system, ragdoll system, troubleshooting physics issues, physics introduction. Oh, Lord. Collision objects, character body 2D, collision detection, provides collision detection. Yes. How? Floor block on wall. What does that mean? If true, the body will be able to move on the floor only. This option avoids to be able to walk on walls. It will, however, allow to slide down along them. Block on wall. Okay. In addition to the general collision detection provided by physics body 2D move and collide, this makes what? Specialized for class is a specialized class for physics bodies that are meant to be user-friendly, user-controlled. Oh, Jesus Christ, definitely not user-friendly. I'm reading the character body 2D docs right now, documentation page. They are not affected by physics at all, but they affect other physics bodies in their path. They are mainly used to provide high-level API to move objects with wall and slope detection. Move and slide method. In addition to the general collision detection by physics body 2D dot move and slide, this makes it useful for highly configurable physics bodies that must move in specific ways and collide with the world, as is often the case with user-controlled characters. Well, okay. But can somebody please tell me how do I check the collision? I don't want to be here for 5 hours figuring out how to detect collisions. Slippery on walls. Wait. That means that if I toggle this off... No, it doesn't. Okay. Lock on wall. If true, the body will be able to move on the floor only. This option... Hold on. Yeah, I don't know what that does. Yeah, it doesn't seem to have really done anything. What happens if the block falls on you? What did you expect? Okay, so moves the body based on velocity. If the body collides with another, it will slide along. Okay, blah blah blah. First velocity. Slide. What? To get the latest collision, call get last slide collision. For detailed information about collisions that occurred, use get slide collision. What? Okay. So if I just do something like this and do get last slide collision, and then I print the collision. What on earth are you complaining? Identifier call not declared in the current. Okay, so now you can't see it. You can't see it. Was half expecting it to glitch you out through the bottom platform for some reason. Rigid bodies don't suck. Yeah, of course they don't suck. But what you can't see right now is the massive amount of collision detections that it's printing. Let me just hide all of that. There we go. And it appears that we have collision detection. Okay, so does the detected collision object then, does it have a position? If I wanted to say set the position of the character just as a test. Wait, no. We do this equals call dot get position. Okay. Position, transform position, p position, position, position. You know what? You know what? You know what? You know what? Is there apply floor snap, apply scale, force update, get platform velocity, is transform not, oh Jesus. Performance, no. Is on wall. Is on floor only, is on floor, is on ceiling, get wall normal, is on blah blah blah. Get slight collision count, get slight collision, get real velocity, get position delta, get platform velocity, get last motion, get floor normal, get floor angle, apply floor snap. But what? What is the move toward then? I can't find the move toward on the docs. What is the move toward a thing of? Where is move to? Oh, move toward is a vector function. Method. Vector method. Okay, cool. Y equals. Actually, no. Velocity equals. Crap. Actually, get last motion. Negative one. What did I do? Something tells me GDS is very slightly inconvenient to learn. If you don't know how to read the documentation, then yeah. Okay, let me see. Oh dear God. Oh dear God. Oh dear God, I got stuck. Hang on. I don't know what I'm doing. Oh. Hello and welcome. Okay, so we're just gonna have to like program this some other time. Because I needed to program the state machine as well. So we know when the player is in the air. But holy crap! Okay, what was that about? Okay, well, we need to program uh, the state machine. Okay, we're gonna have some states then. So enum states on wall, on ground, falling and jumping. On wall, on ground, falling and jumping. I don't know if we're actually gonna use on wall. I'm thinking yes. On ceiling we're definitely not gonna use, so we don't need on ceiling. Then we're gonna have, let me see. We're gonna have a state, or state underscore state. So, yeah, that's far too long of a list to read. Where are all of the built-in methods? All the built-in events? Uh, I guess they aren't even called events, but okay, what the heck? What the heck is physics process then? Methods? Main loop. Oh? Oh! Oh! Finalize, initialize, physics process and process. Oh. Okay. That's great. Var state equals. Let's see. Actually, so we need to define that it's gonna be an integer state, which will be an index of the states list. Oh dear God, this is gonna be a mess. Int? Are you sure about that? Okay. Is a data type consisting of a set of named values called elements members in normal enumeration type. Okay, yeah, sure, we'll go with it. Okay, where is jumping? Bool states on the ground. For the love of Christ. Is on floor. We would replace this with state equals No. States dot on ground. That's not gonna do anything yet, because we haven't assigned the state ever. And that is something we need to do. So, dear God. Is jumping... This is the most painful way to learn, but it is the best way to learn. To just do it and fail over and over again. But anyways. Round. Now how do we... Press ground. Jumping. Okay. If state gliding else if state gliding, we're not going to have a gliding, we're going to have a falling. See, where do you do the jump in this? If is jumping, yeah, but move up. State equals no, not that. State equals state gliding, no, not that either. Calculating vertical velocity. Gravity, glide, gravity. Where in God's name did you assign that? Not even making a glide function. Glide gravity if state gliding else base gravity velocity y gravity delta is jumping impulse glide jump impulse if state gliding else jump impulse velocity dot y jump impulse state dot in air. What in God's name does any of this mean? Okay. Let's see. Velocity to x, you assigned that. Okay, cool. And velocity to y plus equals gravity times delta. I'm gonna lose my mind reading this. Velocity y, jump velocity is on floor. What? Change state, new state info. Oh dear lord. Initialize the new state. Match states to in air speed. What in God's name does this mean? Will you put this game on Steam? No! It costs $100 to put a game on Steam. I'm not doing that. Is jumping bool states dot on ground and input is action just pressed move up? What in God's name are you warning me about? State is declared but never used in the script. Thank you for telling me the obvious. No, I saw it already. State on ground physics delta float. Why would you even declare that? Are we speaking in the same language here? God no. Okay. Okay. Uh-huh. 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 Okay. Cool. Yep. Mm-hmm. Why is everyone on YouTube nowadays so quiet? Like, literally every Godot tutorial that I have seen today has been so quiet. I've had to crank up my volume to ear rape level. Like, why? They know how to program. Can't they increase the damn volume slider? Uh-huh, yeah, cool. Yeah, you're gonna have a match switch state. What? Yeah, yeah, cool. Yes, awesome. Yes, yes, yes. What? 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 Why is it every stream that my nose just becomes really itchy? Like, any one of these streams, I'm going to become Voldemort. I'm gonna lose my nose. Match current state. Idle. Pass. Okay. Huh? Awesome. Cool. Oh, hey, there's the move and slide. Now I found it. We're gonna just remove all of this. We're gonna do extends the body 2D. And we're gonna do a list of enums again. Oh yeah, I forgot. Idle. Running on wall. Jumping and no. Idle running, on wall jumping, falling. Eh? Yeah, sure, whatever. Of course, we're gonna need the current state. I'm not gonna follow the way this person codes because, God, I'm not used to that. We're gonna make it states.idle. What's the point of this? Now hold on. Hold on a moment. What? But this guy isn't even programming a player. I'm programming a player. This guy's programming an NPC. I'm gonna start doing art streams after this. I swear to God, I'm gonna start doing game art streams after this. And then once I've figured out more of programming in Godot, I'm actually gonna start doing good streams on programming. I'll switch. This is a 7-minute tutorial, sure. Oh. So I swear to God, this I did not expect this to be as difficult as making a square rotate in Pygame. I mean, I did make it rotate. It just didn't rotate the way I wanted it to. Let me look at this now. Why do we have this tile map here? We don't need the tile map right now. What? 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 Huh? Hmm. game objects will be particular state, just such as waiting, jumping, and running. In order to change state, some event occurs, such as a key press. State machine, state 1, state 2. Okay. What? I'm gonna add a node, and we're gonna add a couple other nodes inside of this node. These are gonna represent the states. This one's gonna have the actual, this one's gonna be the actual state machine. We're gonna give it the state machine script. We're gonna have those. Okay, so the state machine controller code extends node, and we need to give it a class name. I'm just gonna follow what this does, whatever this tutorial does. Is this in... which version is this in? I don't know. Debug true. More history. Function already. Change to back. Enter state. State.fsm. What? Knowing my luck, I'm gonna write all of this, and then I'm gonna find out that it was all written for Godot 3.1, and I'm actually like one whole version ahead, and that's gonna ruin the whole script. But let's hope that doesn't happen. Okay, so sure, we're gonna, this is what we're gonna do now. We're gonna do all of this, const debug equals true. I'm gonna write all of this, and I'm gonna hopefully learn something from it. Var state object object var history function ready state equals get child 0, because that gets the first state, which is this, and this we would call idle. Okay, and then we call the enter state function, which we're going to implement in a moment. But first we're gonna, yeah, you know, no, we're gonna make the enter state func enter state. Why didn't I start with this? If debug, this is why we have the debug, so we can just print the state that we're going to enter. So entering plus, no, let's just do state dot name, and then outside of that we're gonna do state.fsm, which I'm not sure what that is, but I assume that we're gonna write that later. Equals self fsm okay, so that sets it to the current script, so the state machine. Okay, state dot enter. Then we're gonna do the thing up here, which is underscore enter state. And we also need a function called back for some reason. I don't know what that is. I didn't write a history. No, I did write the history. The history is right there. So I assume that we're gonna go back a state. I start to understand now what a state machine is. History.append. No. That's for the change, which I didn't write and I skipped over. If history.size bigger than 0, because we can't really go back if there's no history. State equals get node history dot pop back, and then we're gonna call enter state like so. We're gonna do the change function as well. Change to function. And this is gonna take new state. We'll just write the same way. I need to learn how to write a proper GD script. History.append. Now, don't you dare think that I am this smart. I'm just reading a tutorial here, so I can understand and learn a bit about state machines. Equals get node. And I do understand what all of this does. I just don't get the point in it yet. But I'm sure once it's done, I will understand. But from what I'm gathering right now, a state machine allows us to easily switch between all the different states, such as idle, running, in the air, on wall, or even like things like sliding. And that is why it's so convenient and good to have. Ow, Jesus. I just poked my chest really hard with my thumb. Ow. Okay. There's state history. History append. So first we append to the history. When we're changing to the state, we append to the history the state's name. So therefore the history increases. Okay, we add it to the history. Got it. Then we set the current state to the node, which is in here, which goes by the name new state. And then we enter that state. And the enter state switches something within the state, which we haven't written yet, which we will write in a moment. But now we're gonna go on a tiny break, and I'll be back in a few minutes. We are back. I forgot that I muted my microphone. So, now that we're at this point, right. So we have the ready. We have change to new state. We have back, which goes back into history. We have enter state, which allows us to easily enter a new state. Then we're going to need the Oh, I understand now. Okay. So we need to include game loop functions in case the state has a method for it. So we're making a really advanced state machine here, but once you make it and once you understand it, you don't need to make it ever again. It's permanent. It's one and done, basically. Then it's super easy and modular to use. I'm gonna remove this here. We're actually gonna change this to game loop functions. And this is the process, so we're just gonna do if state dot has method process. So this checks if one of these states, or the current state, has this method. And if it does, then state dot process with the delta, which we get from this. So this is the actual game loop function which runs, and then if we if the state has the method called process, then we'll basically just pass we'll basically just run this same function in there with the delta. I can't explain properly, which is why I don't do tutorials. This is not a tutorial. Disclaimer, this is not a tutorial. I'm just explaining this to myself, basically. I need to explain it to myself so I can understand it better, because this is the first time that I am writing a state machine, and apparently I decided to start from the absolute most advanced thing ever, because this has even game loop functions. So now we're gonna do the physics process. We're gonna do input, unhandled event, unhandled input, unhandled key input, notification, and so on. Actually, no, they're not so on, because that's all that there is. So physics process delta, if state dot has method. Oh dear God, what's happening? That is Steam, that's happening. Okay, there we go. I don't know why it does that. I have it on Steam. I have Godot on Steam because it's more convenient to update. But we're gonna check here if it has the physics process method. Yeah. And then we're gonna run the state dot physics process with the delta from here. Physics process delta. Okay. Then we have input func underscore input event. And we do the same thing if state dot has method inputs, then we'll want to call state dot input with the event, with the input event. Then we do func unhandled input, which I'm not too sure why it does. Unhandled inputs. But we're gonna do this anyways. As method. Oh, it happened again. Unhandled input. Then we call state dot unhandled input with the event. There. And we have function unhandled key inputs if state dot has method. Okay, I see. As method unhandled key input 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 state dot unhandled. You know what, I'm just gonna copy this from here because it's the same, and then we pass in the event. Okay. And then finally we have a notification. So func notification. I'm not sure what notification exactly means, but I'm sure that it'll come in handy. Then we check if state. So apparently we don't need to have a state for us to receive a notification. State dot has method notification, but this goes still the same way. We just call state dot notification with the what. There. Okay, we give the script a class name. We have, okay, so I'm gonna read this out for all of you. Wow. So we give the script a class name so that it will be available as a custom node in the editor. Yes. The custom node in the editor. Wait, so that means nope. Nope, that's not what it means. Oh, that it is, but it is, oh god, it is what it means. It does show up there. That's epic. Okay, and then there's a debug constant for debugging purposes, outputting messages into the output window. A state variable will hold a reference to the current state node, which is right here, and the state nodes will be parented to the state machine. A history variable will hold a history stack, array of state names. The name property of the state node will be used for the name of the state. So any of these states can be added to the history as we go through them. So when we're changing from one state to another, we would called this, and we before switching to the new state, we set the current state's name, we append the current state's name into the history list so that we can keep track of the that. Okay, yeah, sure. And then we can go back if we need to, which we will, because that's the point of a state machine. Right? Right. The ready function, the initial state is set to the first child node. Hang on, I just have to check that yes, I did switch my scene back to back in OBS to the right one. So in the ready function, the initial state is set, yes, as the first child, and these children act as the states, which is why I just kind of decided to name that to idle. The change to function takes the new state node reference. The change to function takes the new state node reference, so that, and sets the current state to this, so the current state, and pushes the previous state. What? Oh yeah, pushes the previous state onto the history and sets the current state to the new state. And then it calls the enter state function. The enter state function sets the FSM, aka finite state machine, of the current state to this state machine. So if I was to read this whole thing here, the enter state function sets the FSM finite state machine property of the current state to this state machine controller, so this, so that the state exit function may access the common functions without needing signals or getting its parent. Then the enter function of the new state is called. So these will eventually have a enter and an exit function, which can be called. The back function checks if the history stack has items, and if so, pops the last one off the stack and enters that new state. So it basically just pops it and enters the new state, because it assigns the state to the last item that is at the very back of the list, at the very end of the list. It pops it off of there, and it assigns the current state to that, and it enters that state. Whew. This is still somewhat understanding. Oh god. Okay, this is still somewhat understandable. When the game is running, various override methods may be called, such as process. So these are all implemented with a test of if the current state is able to handle the method. Alright. In order to handle one of these methods, the state should implement a function of the same name minus the underscore prefix. This is so that only the current state will respond to the event that trigger these functions. Current state will respond to the events that trigger these functions. Okay, got it. That's a hell of a lot of things, but now we can finally We can finally get to the actual state script. Boy, oh boy, this is gonna be fun. We're gonna name this state, and I'm gonna first of all start by reading this. The state handler code, which will go in here into the state. We're gonna attach a state script to here. We'll call it state handler, and we won't have anything there. And now it's just extending node. So the enter function will perform initialization. It will initialize and run any startup code for the state. Okay. So when... What? Okay, when it starts up, if we need to prepare anything, we can do it in there. Okay, got it. The exit function will call the change to next state method on the controller. Okay. The exit function will call the change to state wait, no, I read that already. God. What the state does while it is current... What? What the state does while it is current depends on its internal logic. So when it is the current state of the state machine, it depends on the internal logic of the state. So maybe we would implement the process delta function or input event function depending on what we want to do. And somewhere within this logic, we would call the exit function with the name of a new state to transition to. Oh dear God. I'm losing track of everything right now. Okay. So maybe we would implement the process delta function or input event function depending on what we want to do. Got it. And somewhere within this logic, we would call the exit function with the name of a new state to transition to. Got it. Does it? Yeah, sure. Got it. So we're gonna make the state handler now. So first of all, we're gonna need the FSM, which stands for finite state machine, and it's gonna be the state machine of type state machine because that is a class. We have given it a class name, and we're gonna have the enter function. We don't need to print anything here. The example does, but I won't. And then it's going to exit 2 seconds later. So yield get 3 create timer 2.0 timeout. Do we have to do that? Okay, sure. Will yield. Will yield. Get 3 dot create timer 2.0 timeout, and do that. and then we're going to call the exit function, which we're gonna write in a moment. And then this would have the next state. Okay, got it. That shouldn't show an error. Yield was removed in God of War. Just okay. Thanks for at least telling me. Oh, sweet Jesus. Okay, how does await function? Okay. Func exit next state fsm dot change to. Now this that. Perfect. Okay. Oh dear Lord. I feel like we might want to also make a state class so that we can easily add a new state and we don't need to like copy the state. Anyways, then we can enter any of the handler functions. Then I'm gonna write this down and then I'm gonna comment them out. Physics process. Unhandled input events return events unhandled key input events return event func notification what return what flag. Now since these are optional, signature is notification input if what. Oh, it's a notification overrides. I don't even know what notification is. Notification. Notification. Oh. Notification received from the OS when the application is exceeding its allocated memory. What? Okay, let's see. Every object in Godot implements an underscore notification method. Its purpose is to allow the object to respond to a variety of engine-level callbacks that may relate to it. For example, if the engine tells a canvas item to draw, it will call notification draw. Some of these notifications, like draw, are useful to override in scripts. So much so that Godot exposes many of them with dedicated functions. Oh, so notification is essentially like the core of underscore ready, underscore enter tree, underscore exit tree, underscore process, and so on. Okay, so what users might not realize is that notifications exist for types other than node alone. For example, object notification post initialize, a callback that triggers during object initialization, not accessible to scripts. And then some others. Hmm. Wait. Underscore notification. Did that have anything? No, it didn't. State on notification. Turn what and flag. Turn what and flag. What flag? Notification overrides a method from native class object. This won't be called by the engine and may not work as expected, which is a warning treated as error. That's not needed. Okay, well, this, I don't know what to do about this then, because I feel like I might need the notification, but also I might just do notif and then change this in here to notif. And now we're going to put all of these in comments. So we're gonna hit Control K on all of these. Do I not have a write control? What? How did I never realize that my keyboard doesn't have a right control? It has a left control. Okay. Sure. But we're basically just gonna disable all of these, and then we can enable them as needed. Actually, not that. That, oh god. Enter and exit are the two things that we don't want to comment out, because they are too necessary. The rest of these are optional. Okay, so 10. We can do the same thing for the next state. But we can also, I'm pretty sure that we can do class name state. Or state handle, state machine state. And this way, we have a state machine state and a state machine. Can we give these guys like descriptions? I don't think so. But that's the whole state machine done. We just need to implement functionality. Hang on, if I add child node and we add this, okay, let me read through this now. The return statements were added to suppress compiler warnings where values are unused. But now, by adding an underscore prefix to the input variable, it will be silently ignored. Yeah, sure, whatever. This code may be copied and customized for each new state. Okay, so we can't make it a class. Because if we made it class, it would use the same script for all of them, and we sort of just need to like turn this state into its own node, but each state have the same not same script, different script, but the same content of the script. God. Okay, concurrent state machines. In your game, you may need to know what the state of another finite state machine is where the context is important for decision making. So for this, you could have a dictionary of your finite state machine references and their current state in a global data variable. So maybe move the state variable out of the scope of the state machine script. Oh god. So maybe move the state variable out of the scope of the state machine script in and into the global context autoload singleton. What the heck am I listening to? Okay. Global context autoload context. Oh goodness gracious. Okay, well at least we have the entire state machine done. Now I just need to figure out how to utilize it. That's gonna be the problem. So, if we duplicate this, right, make unique. No, edits, clear, quick load, state handler, make unique. Huh? Okay, so technically speaking, we can we 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 okay, let me delete this. Yes, I'm gonna delete that. And this I'm gonna close as well. Discard. So if we do class name state handler, then we're going to have a new thing here called state handler. If we create one of those, we're going to have what's essentially a new state. Now, however, this shares the same script as the first state, which we don't want. So what we can do is just inherit state handler, create. So, what? Oh dear God. Oh goodness. Goodness me. Um if something extends the state handler, means that it inherits everything from it, but these just gonna become useless. Do these need to be commented out? I'm guessing that they don't. But like, this is currently extends state handler. Oh lord. Okay, at least I understand more about what a state machine now is. I understand why it does. So now I can look at the more advanced version on the other page. Yeah, I understand what this does. That's the state class. Okay, they make a class for the state, just like I just did. They have a handle input, they have an update, they have physics update, they have enter, they have an exit. Okay. So then that's the one that's created in the state. I really do feel like I do not need to comment these. And we also don't really want to return any of these. So class name state machine extends node signal transitioned state name emitted when transitioning to a new state. Okay. Export var initial state. Path to the initial active state. So that is an improvement to this. Am I gonna have to rewrite this whole thing? So there's a transition signal, which is emitted when transitioning to a new state. So path to the initial active state, which can be set in the properties, the inspector. Then we have the current active state. We get the initial state. On ready, we yield was removed. Yield was removed in 4.0. I can't do that. The state machine assigns itself to the state object's state machine property. Okay, that's understandable. For child in get children, child dot state machine equals self state dot enter. Okay. The state machine subscribes to node callbacks and delegates them to the state objects. State machine subscribes to node callbacks and delegates them to the state objects. Okay, so it just has some callbacks that the state machine will really handle when that, oh god, state.update delta. No, they're optional. Yeah. Then this function calls the current state's exit function, then changes to active state. It optionally takes a message dictionary to pass to the next state's enter function. Target state name. I mean, this at its core, this all just does the same thing. Just the only things that are different is the class, and it seems like this that one is just more complex. It also doesn't have any of the history. If not has node target state name, then we return state dot exit state get node target state name state enter with a message. Emit signal transition to state dot name. Okay, applying the state pattern to our player. Oh Lord. Okay. So that'll extend the state. Func enter update. Oh dear God. Class name state handler. This does bring me back to the times when I started out with Roblox Studio, and I had pretty much no clue what the clue with a C. I had no clue of what I was actually doing, but I just kept doing until I started understanding, and that's the way I learned then. Okay, so state there with a message. We must declare all the properties we access through owner in the player GD script. Owner. Oh yeah, we're gonna pass on these. I believe that we probably won't need this. But we're gonna pass on that as well. Okay, so just gonna check to make the system work even if states try to transition to a non-available. Okay. The state objects will take control of a host. In our case, it will always be the scene's root node. To that end, we set up our scene structure with the kinematic body to the... Oh, Jesus. Bar on... Huh? Let me put this up at the top. Export. Okay, in that case, we're just gonna have that like that then. I don't know if export was like removed or export. No, not that. No, it couldn't have. But like, that's odd. Okay. Class members can be exported. Oh, did I skip over that completely? No, that's just written incorrectly. Why would I ever follow that then? um, Okay, that guess we're just gonna do... How did that go? State versus state object, okay. So then I'll assign this as the default. And that should function. I hope, at least. Adding auto completion. God, no. I don't know how old this is. But sure seems 2021. This is 2 years old. Jesus. Most of these things have changed since then. A lot. But anyway, how would I actually then... How would I actually utilize this? I mean, this should theoretically now function just fine. I just need to make that work, like the class for it. That's what I'm gonna use this author guide for. We'll create 3 new scripts that extend state, one for each of 3 states our character will have. So it'll extend the state handler like this does right now. And what do they do in the code? They have the enter function, which is already in the state handler's code. Enter pass. Okay, well, I mean, and this doesn't have any message. Yeah, that doesn't have any message. We can implement messages through state.enter here. If we pass some sort of message to this, so we'll just need to enter a message into all of these. I don't know what the heck that is complaining about. Oh, yeah. Right, those don't know what the message even is. Too few arguments. We'll default the message to null. But we can still pass something into there. And then it'll pass the message that this gets into here. But I also won't complain. Or a better way to do it is to add an underscore. Oh, never mind. I thought that was it. Well, I mean, this quietens it, so I suppose we don't need to really worry about that then. And as long as every enter state well, actually, we'll need to make it so the back receives a message that it passes on. Where is back called? I don't know. So we'll just have we'll have to do this in all of these. No, that's an odd song that I was listening to. No, thank you. So, of course, the message isn't necessary at all. Then we'll pass through the message. I don't know, I'm pretty sure that there is a fancier way of doing this, but I don't know it. But I think they should make it so it defaults to null, but if it does receive something, then it'll pass it through here. And then when we call to enter, we can have a message in here to pass into the new state. And that should be good. But then if we want to enter the message, then we also need to assign it to null here as well. You know, in case we don't. In case we don't have a message. Then FSM change to next state. And this needs to receive an optional message. And then we pass the message regardless of if it is null or not. We pass the message into the change to. Okay, so I'm gonna delete the state2 for now. I'm gonna rename this, if I can. Hang on, state handler. Oh, we have state2 there as well. Let's delete that. So state handler, rename state. That'll close it, but we still have it there. Perfect. Class name state. What's the problem? State hides a global script class. Okay, fine. What? Okay, well, I mean, it makes sense. Okay. Okay, now that's using the state.gt script. Hoo-wee. Making a state machine when you understand nothing about state machines. Perfect. All right. So then when we make a new state, well, making a new state is actually very easy now. Making a new state is actually... Excuse me? Okay. If that is the case, then we'll have to change this name back to state handler. And that should be good. Okay, it seems that we just can't have the class name and the script name the same, which I suppose makes sense. But now we can add that. That'll be named to that, and we just need to extend the script like that. Because we can't have it be the same script. Also, I feel like we might need to actually put the state handler in its own scene. Yes. Just any state machine state. Then we're gonna remove them from here. Oh, well, it's perfect. State machine TSAN and state machine close save. Oh, sweet Jesus. Okay, so this has that. If I duplicate the state machine, what about state 2 then? Good God. No, it didn't duplicate. What? Just close that and open the state machine. And that's good. This, however, should have oh god. Nope, that doesn't work. Okay. Okay, I'm gonna detach and oh dear god, what are you? Close, discard, and attach an existing one, thank you. This is the state machine. So load. Perfect. And state handler, open, load. Okay. That's perfect. Oh. How long has it been? 3 hours? Jesus. 7 p.m. already. Oh, okay. Well, at least I accomplished exactly what I set out to accomplish, but just we are lacking a movable character now. Well, actually, yes, we are we are lacking a movable character. We cannot move anymore. But that's gonna be a worry for another time, I suppose. Right now, I feel like I need to rename this, honestly. Can I? Okay, that fixes up some things then. That's much better like that. And this can contain the original state machine and the original state. Then we can extend the state. Can we extend it? No, hold up. Hold on. That's the machine, yeah. And the first, okay, so the individual state scripts then would extend the state. Call that idle.dg, not gd, yeah, gd. Idle.gd would be what? Player state run.gd extends player state. Jesus, player state extends player state. Class name player state extends state. Typed reference to the player node, player, ready? Yeah, owner, player, owner's player. Owner. I'm looking at this guide here, and I mean, I know that it's really outdated. But I have no idea what on earth is the owner that they're talking about. Like what is owner? What is owner? Owner is a node property that sets automatically when you save a scene. That's set. That's set automatically when you save a scene. Okay. Parents and owners. A node's owner is one that the node will be saved along with. Backed scene owner is the root node of that scene. Group of nodes for the player. Okay, so the owner is the root node. Node's parent is a node that is one level up from the node's hierarchy. A node's owner is one that the node will be saved along with. E.g., if you make a node from script in the editor, it will have a default owner of null. Therefore, it won't be saved with the currently edited scene. Okay, to keep track of the scene hierarchy, especially when instancing scenes into other scenes. An owner can be set for the node with set owner. This keeps track of who instanced what. This is mostly useful when writing editors and tools. So the owner... What? Okay, owner dot velocity. Owner dot velocity. Okay, I'll get more knowledge on that. But for now, I think it's time to end the stream. Because it is getting about that time. And I'm hoping that next time, whenever that is, I don't know yet, I'll maybe do an announcement on my Discord server about that. Who knows? I'll put up the stream then, like at least an hour before it starts. And then I'm hoping that for the next time I'll have figured out entirely how to do the state machine. And then we can have the next stream be more of an art stream and level building stream. And yeah, that's it. So, thank you for being here. thank you for not being here. And I am going to see you maybe in a couple of days, maybe tomorrow. I don't know yet. But thank you for being here once again. Thank you for not being here. I'll see you whenever. Bye.